Okay, stationary points slash second derivatives. All right, in this diagram, diagram was taken straight out of a textbook. You have a maximum and minimum values. So this is some function. This is a graph of some function. You have 4 points on it: points A, B, C, and P. All right. Now, point A and C are maximum turning points. All right. So you can see the graph go up to A and then turn and then start come back down. So A and C are classified as maximum turning points. Now the gradient at A and C is equal to 0. And essentially the tangent at A and C would be a horizontal line. And the gradient of the tangent, which is equal to the gradient of the function, is 0. The gradient before the point C or the point A is positive. You can see that for yourself. The line here is indicating that the gradient before A is positive, because if from left to right, if the line slopes up, its gradient is positive. All right. So the gradient just before A and C or C is positive, and the gradient just after A or C is negative. So at the maximum turning point A and C, the gradient is 0, but just before C, the gradient is positive, and just after A and after C, the gradient is negative. So the range of values of gradient about a maximum turning point is positive, 0, and negative. All right, now C is called a minimum turning point. The gradient at, sorry, not C, B is a minimum turning point. The gradient at B is equal to 0. The gradient just before and just after B is negative and positive, respectively. So for a minimum turning point, the gradient sort of like moves like this. You have negative, 0, and then positive. The gradient changes from negative to 0 at B and positive just after B. So that's at a minimum turning point. P now in the diagram is called a point of inflection. Let's see what we have written here about P. P is called a point of inflection. The gradient just before and just after P have the same value. So if you look carefully at this diagram, you see that the gradient just before P is negative and the gradient just after P is still negative. If you have a situation like that, what you have is a point of inflection. All right, stationary points. Let y be f of x. Stationary point of y occur at dy by dx is equal to 0. So in other words, at a stationary point, the gradient of the tangent, the gradient of the function is equal to 0. Example 1. Find the stationary point of y is equal to x squared plus 2x minus 1. Alright, so the first thing we need to do is find the value of x at the stationary point. To do that, I'm going to find the first derivative. Dy by dx is equal to 2x plus 2. Now, at stationary points, dy by dx is equal to 0. So therefore, 2x plus 2 is equal to 0. So this is true only at the stationary points. So here we're going to have 2x is equal to minus 2. Divide both sides by 2. We're going to have x is equal to minus 1. So therefore, what this is telling me is that the value of x at the stationary point is x is equal to minus 1. Now I can plug this value of x into the equation at the top here. Plug the value of x into the equation in order to get the value of what? Y. So I can say when x is equal to minus 1, y is equal to minus 1 squared plus 2 times minus 1 minus 1. So this is y is equal to 1 minus 2 minus 1. So y here is minus 2. So therefore x is minus 1, y is minus 2 is the stationary point. So to recap, we're asked to we're asked to determine the coordinates of find the stationary point. So in a sense, we're asked to find the coordinate of the stationary point. The first thing I did, I used the fact that at the stationary point, dy by dx is equal to 0. So I find the first derivative and equate that to 0. And what that did for me is that gave me the value of x at the stationary point. I then substituted this value of x into the equation to get the corresponding value of y. So x is equal to minus 1 and y is equal to minus 2 are the values of x and y at the stationary point. Example 13, it says find the coordinates of the stationary point. So it's a similar idea. So y is equal to x cubed minus 3x plus 1. So dy by dx is equal to 3x squared. The power comes to the front and you decrease the power by 1 minus 3. Alright, and whenever you decrease 3x you get 3. Whenever you decrease 1 you get 0. Now at stationary point, dy by dx is equal to 0. So therefore 3x squared minus 3 is equal to 0. Divide the entire equation by 3. I'm going to get x squared minus 1 is equal to 0. Let's factorize. We're going to get x plus 1, x minus 1 is equal to 0. X squared minus 1 is the difference of two squares, and this is how we factorize the difference of two squares. Therefore, x plus 1 is equal to 0, or x minus 1 is equal to 0. Therefore, x is equal to minus 1, or x is equal to 1. Therefore, so what I have here are the values of x at the stationary point. So let's get the corresponding values of y. I'm going to say when x is equal to minus 1, y would be equal to, back up here, x cubed minus 3x plus 1. So it's minus 1 cubed minus 3 times minus 1 plus 1. So this is minus 1. Whenever you multiply 3 negatives, you're going to get a negative, plus 3 plus 1. So here y is 3. So minus 1, 3 is a stationary point. I can say also when x is equal to 1, y would be equal to 1 cubed minus 3 times 1 plus 1. Y would be equal to 1 minus 3 plus 1, which is minus 1. So the next stationary point is 1 minus 1. Example 14. It says find the coordinates of the stationary point of y is equal to cos x for values of x less than or equal to pi by 2 but greater than or equal to 0. Alright, so here we have y is equal to cosine x. Then I'm going to say dy by dx. Differentiate cos, you're going to get minus sine x. So what I'm doing here is I'm trying to find the value of x at the stationary point. So then I'm going to say at stationary point, dy by dx is equal to 0. So therefore, minus sine x is equal to 0. Sine x is equal to 0. Divide both sides by minus 1. If I know the sign of a function, it's the sign of something to find. If I know the sign of an angle, to find the angle, I must go sine inverse. So this is sine inverse of 0. And so sine inverse of 0 is 0. So within the range, x is less than or equal to 90 or pi by 2, or x is greater than or equal to 0, the value of x at the stationary point is x is equal to 0. So now I know what the value of x is at the stationary point. Now I need to determine the value of y. So I'm going to say when x is equal to 0, x is equal to 0 is the value of x at the stationary point. Y would be equal to the cosine of 0, and the cosine of 0 is 1. So therefore 0, 1 is the stationary point. 0, 1 is the stationary point. Alright, example 15. It says find the coordinates of the stationary point of the curve. So the curve is y is equal to 2 cosine theta plus sine 2 theta. Alright, we need to find the value of theta at the stationary point. So to do that, I have to differentiate dy by d theta. Differentiate cos to get sine minus sine, so it's minus 2 sine theta. Differentiate sine to get cos, so this is 2 cos 2 theta. So you differentiate sine and you get cos, but then you have to multiply by the differential of the inside function. The inside function is 2 theta, and if you differentiate 2 theta with respect to theta, you're going to get 2. Alright, now at maximum and minimum, at stationary point, dy by dx is equal to 0. Alright, so what we're going to have is minus 2 sine theta plus 2 cos 2 theta is equal to 0. Alright, by looking at this, I think I can turn it into a quadratic. because I think that cos 2 theta is the same as saying 1 minus 2 sine theta. But before I do that, if I wanted to, I could divide the entire equation by 2. So now I have minus sine theta plus cos 2 theta is equal to 0. I can say minus sine theta plus 1 minus 2 sine square theta is equal to 0. Alright, so what I have is minus 2 sine square theta minus sine theta plus 1 is equal to 0. I could multiply the entire equation by 1. So I'm going to have 2 sine square theta plus sine theta minus 1 is equal to 0. So quadratic equation, so let us factorize. Well, I hope it can be factorized. Is equal to 0. Two factors, you should be able to factorize it. So I have 2 sine theta sine theta. Obviously, you're going to have 1 and 1 here. One of them has to be plus. I'm guessing this is plus, and the other one minus. Alright, I think that this is correct. 2 sine theta minus sine theta. Yeah, this is correct. Therefore, 2 sine theta minus 1 is equal to 0, or sine theta plus 1 is equal to 0. So, sine theta is equal to a half, or sine theta is equal to minus 1. Alright, so the answer I'm going to reject, I'm going to reject one of these answers, and I'll tell you why. The examiner says he only needs values of theta between what 0 and 90, and sine is positive in the first and second quadrant. So if sine is minus 1, it means that it's outside of the scope of values of theta that I need. So I don't need this. I'm going to reject that. So sine theta is equal to a half. It means that theta is equal to sine inverse a half, and this is 30 degrees, and 30 degrees I believe is what 30 degrees is pi by 6. So this is pi by 6. So what I have is the value of theta at the stationary point. Now that I have the value of theta, what I need is the value of y. So when theta is equal to pi by 6, y, which is 2 cos theta plus sine 2 theta, so y, which is 2 sine theta, which is pi by 6. Let's see if I got that correct. 2 cos theta sine 2 theta. So this should be 2 cos theta. So it's cos pi by 6 plus sine 2 times pi by 6. Alright, 2 times pi by 6 is pi by 3, which is 60 degrees. Alright, let's see if I remember. The cosine of 30 degrees. I'm sort of picturing this thing in my mind's eye. The cosine of 30 degrees is cosine is adjacent over hypotenuse. So this is equal to 2 times root 3 over 2 plus the sine of 60 degrees. Then the sine of 60 degrees is actually the same thing. Root 3 over 2. This is root 3 over 2. Alright, so this is 3 root 3 over 2. So the x value is pi by 6, and the y value is 3 root 3 over 2, and this point is the stationary point. This is the stationary point.